Hello, in this lecture we will find the area of the green triangle. In the drawing we have square ABCD. We know that one side of square ABCD equals to 4 units, and inside this square ABCD, we have a circle. This circle and the radius of this circle equals to 1 unit, and we want to find out the area of this green right triangle. So first of all, I will present to you a new rule number 1. According to rule number 1, a tangent to a circle tangent to a circle is perpendicular to the radius. Drawn to its point of tendency. So I will repeat on rule number 1 again. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have a circle and tangent AB, this tangent AB is perpendicular, is tangent to this circle at this point. Point M is the point of tendency. Point of tendency. Of tangent AB with this circle. Suppose that this is the center of this circle. We will define the center of this circle as point O, and from point O we have radius that touches point M. So this is the radius of the circle R, and as you can see, the radius OM of this circle, it is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent AB with this circle. Therefore, according to rule number 1, the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay, so a tangent to a circle, that is to say tangent AB, is perpendicular to the radius drawn to its point of tangency. So whenever the radius is drawn to the point of tangency, like in this drawing, then the tangent AB will be perpendicular to this radius. That is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, actually we can implement rule number 1 in our drawing, because in our drawing we have this radius. This is the radius of the circle, it equals to 1 unit. We will define the point of tangency of tangent AD. This tangent AD with this circle is point M. So as you can see, the radius, we define the center of this circle as point O. So actually the radius OM, this radius, the radius OM, it is drawn to the point of tangency, that is to say, it is drawn to point M, that is the point of tangency of tangent DA with this circle. Therefore, according to rule number 1, the tangent AD will be perpendicular to this radius, that is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And we also know that the 4 angles inside any square are right angles, therefore this is a right angle, because it's one out of 4 angles that is inside square ABCD, therefore it is a right angle, that is to say it equals to 90 degrees. We will define the touching point, we will define the point of tangency of tangent AB, we will define the point of tangency of tangent AB with this circle as point N. So this point is point N. And then we will join points O and N together by a straight line. Actually, ON is the radius of this circle, because of the fact that line segment ON starts from the center of the circle, that is to say from point O, and ends at point N, that is the point on the circle itself. Therefore, ON is the radius of this circle, therefore it equals to R, and R equals to 1 unit. So as you can see, this, the radius ON, this radius, it is drawn to the point of tendency, that is to say it is drawn to point N, that is the point of tendency of tangent AB with this circle. Therefore, the tangent AB will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay? In the next step, we will define the point of tendency of tangent CE, this tangent, with the circle. We will define the point of tendency of tangent CE with this circle as point K. Then we will join together points O and K by a straight line. Actually, OK is the radius of this circle because of the fact that line segment OK starts from point O, that is the center of this circle, and ends at point K, that is a point on the circle itself. Therefore, OK is the radius of this circle, that is to say it equals to R, that equals to 1 unit. And as you can see in the drawing, the radius OK is drawn to the point of tendency, that is to say it is drawn to this point, point K, that is the point of tendency. Therefore, according to rule number 1, the tangent EC will be perpendicular to this radius. The tangent EC will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. In the next step, I will present to you a new rule, rule number 2. According to rule number 2, the sum of the angles in any quadrilateral is equal to 360 degrees. I will repeat, I write it down. The sum of the angles in any quadrilateral is equal to 360 degrees. Okay, so I'll repeat again rule number 2. According to rule number 2, the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, so actually here we have quadrilateral OMAN, and according to rule number 2, the sum of the angles inside this quadrilateral must be equal to 360 degrees. So if you focus on this quadrilateral MOAN, in quadrilateral MOAN, the sum of the angles must be equal to 360 degrees. So which angles we have in quadrilateral MOAN? Actually we have 3 right angles, 1, 2, 3, and the sum of 3 right angles is equal to 90 times 3 is 270 degrees. 270 degrees plus the size of the fourth angle, this angle, we'll define this angle as angle X. So the sum of the 3 angles plus angle X must be equal to 360 degrees according to rule number 2. Okay? Okay, so according to rule number 2, the sum of the angles in quadrilateral MOAN must be equal to 360 degrees. Therefore, the sum of the 3 angles, that is 270 degrees, plus the size of the fourth angle, that is angle X, must be equal to 360 degrees. So here we will subtract from this equality 270 degrees, and we will get that angle X equals to 360 degrees minus 270 degrees, it equals to 90 degrees. So we found out that angle X is a right angle, it equals to 90 degrees. Okay, we can substitute X by a right angle because it equals to 90 degrees. So here angle X is a right angle. So Actually, as you can see, we have in quadrilateral MOAN, all angles inside quadrilateral MOAN are right angles. That is to say, they are equal to 90 degrees. And we also have rule number 3. According to rule number 3, any quadrilateral that has 4 right angles must be at least a rectangle if not a square, it must be at least a rectangle. I will read rule number 3 again. According to rule number 3, any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So actually, our quadrilateral MOAN has 4 right angles, 1, 2, 3, 4. All angles are right angles inside quadrilateral MOAN. Therefore, according to rule number 3, quadrilateral MOAN is a rectangle. Okay? So we can write down that our quadrilateral MOAN is a rectangle. Quadrilateral MOAN is a rectangle according to rule number 3, because it has 4 right angles. Okay? Quadrilateral MOAN is a rectangle according to rule number 3 because it has 4 right angles. Then we have also rule number 4. According to rule number 4, the opposite sides of a rectangle are equal to each other. I will repeat on rule number 4 again. According to rule number 4, the opposite sides of a rectangle are equal to each other. The opposite sides of a rectangle are equal to each other. So actually, in our specific rectangle MOAN, according to rule number 4, the opposite sides of rectangle MOAN must be equal to each other. So if we focus on rectangle MOAN, according to rule number 4, its opposite sides are equal to each other. That is to say, in rectangle that is to say MO equals to AN according to rule number 4. I repeat again. MO equals to AN according to rule number 4 that the opposite sides of a rectangle are equal to each other. Therefore, the opposite sides in rectangle MOAN, here, rectangle MOAN, must be equal to each other. That is to say, MO equals to ON. Okay? But we know that MO equals to 1 unit according to what is given us in the question. So we know that MO equals to 1 unit. So from this equality, we will conclude that NO also equals to 1 unit. Okay? NO also equals to 1 unit. So we can write here that NO equals to actually here we have MO equals to AN. Okay, here MO equals to AN. So here it is MO equals to AN. Okay, according to rule number 4, MO equals to AN, and we already know that MO equals to 1 unit, and from this equality we will conclude that AN also equals to 1 unit. Okay, so we conclude that AN also equals to 1 unit. Okay, here AN equals to 1 unit. Likewise, according to rule number 4, MA equals to ON. According to the rule that the opposite sides in the rectangle are equal to each other, then MA must be equal to AN in rectangle MOAN. But we have already found out that ON equals to 1. Again, MO equals to ON. MA equals to ON. MA equals to ON according to rule number 1. According to rule number 4. But we have already found out that ON equals to 1. we have already found out that OM equals to 1 and O equals to 1. So from this equality we will get that AM also equals to 1 unit. AM or MA also equals to 1 unit. So here MA also equals to 1 unit. So actually we found out that all 4 sides of rectangle MOAN are equal to each other. They are all equal to 1 unit. And we also found out that rectangle MOAN has 4 equal right angles. 4 right angles. So we can write down rule number 5. According to rule number 5, any quadrilateral according to rule number 5, any quadrilateral that has 4 right angles and also 4 equal sides, then it must be a square. I repeat on rule number 5 again. According to rule number 5, any quadrilateral that has 4 right angles and also 4 equal sides, it must be a square. And we found out that our quadrilateral, the small this quadrilateral MOAN has 4 right angles, 1, 2, 3, 4, and 4 equal sides. All of its sides are equal to 1 unit. Therefore, according to rule number 5, quadrilateral MOAN is a square. Okay? I will write it down. Quadrilateral MOAN is a square according to rule number 5. I'll read it again. Quadrilateral MOAN is a square according to rule number 5 because it has 4 equal sides and 4 right angles. Okay? And we also have rule number 6. According to rule number 6, the diagonals of a square bisect the angles of a square into 45 degrees angles. So I'll read rule number 6 again. According to rule number 6, the diagonals of a square bisects the angle of a square into 45 degrees angles. So according to rule number 6, if we focus on this square MOAN, then according to rule number 6, its diagonal OA, this diagonal OA bisects this angle that is actually a right angle into 2 angles that each of them is equal to 45 degrees. That is to say, this angle equals to 45 degrees in sides, and this angle also equals to 45 degrees in its sides. So actually, this angle that is actually angle OAN is equal to 45 degrees. But we can relate to this angle that equal to 45 degrees also the angle to as angle OAB. It doesn't matter at all if you relate to it as angle OAN or angle OAB, it still will remain anyway, it will remain 45 degrees. So why? Because point N is located on AB, and the 3 points A and B are located on one straight line. Therefore, it doesn't matter at all if you relate to this angle that equals to 45 degrees as angle OAN, or if you relate to this angle as angle OAB. Anyway, it will be equal to 45 degrees. Okay, so we relate to this angle that equals to 45 degrees as angle as angle OAB. So actually angle OAB, if you relate to square MOAN, then according to rule number 6, angle OAB will be equal to 45 degrees according to rule number 6. So I will repeat again. Angle if you relate to square MOAN, then according to rule number 6, angle OAB equals to 45 degrees. Likewise, if we focus on square ABCD, according to rule number 6, the diagonal CA divides this angle into two angles of 45 degrees. So diagonal CA the diagonal CA of square ABCD, the big square, divides this angle into two angles of 45 degrees according to rule number 6. That is to say, angle CAB equals to 45 degrees according to rule number 6. I'll repeat again. In square ABCD, the diagonal CA divides this angle into two angles of 45 degrees according to rule number 6. That is to say, angle CAB, this angle CAB equals to 45 degrees according to rule number 6. Again, angle CAB equals to 45 degrees according to rule number 6. So angle OAB equals to 45 degrees and angle CAB also equals to 45 degrees. Therefore, those two angles are equal to each other. That is to say, angle OAB is equal to angle CAB so here angle OAB is equal to angle CAB. those both angles are equal to 45 degrees. And from the fact that angle CAB equals to angle OAB, we will conclude that the diagonal CA of square ABCD passes for point O. Okay? I'll write it down. We conclude that the diagonal CA of square ABCD passes for point O. I repeat again on our conclusion from the fact that angle CAB equals to angle OAB, we will conclude that the diagonal CA of square ABCD passes for point O. Okay? Actually, the diagonal CA must to pass from point O. Otherwise, if we assume that the diagonal CA doesn't pass for point O, then angle CAB will not be equal to angle OAB. But because of the fact that those two angles are equal to each other, we will conclude that the diagonal CA passes for point O. Okay? In the next step, I will present to you a new rule number 7. According to rule number 7, the length of a diagonal of a square the length of a diagonal of the square is equal to square root of 2 multiplied by the length multiplied by the length of the square's side. So I will repeat on rule number 7 again. According to rule number 7, the length of a diagonal of the square is equal to square root of 2 multiplied by the length of the square's side. So what is the meaning of rule number 7? The meaning of rule number 7 is that if we have square ABCD, so this is square ABCD, and we know that the length of one side of square ABCD equals to S units. So all the sides, all the lengths of sides square ABCD are equal to S units. So if the length of one side of square ABCD equals to S units, then the length of its diagonals BC and AD will be equal to square root of 2 times S units. So if the length of one side of square ABCD equals to S units, then the length of its diagonal BC and AD will be equal to square root of 2 multiplied by S units. And we can calculate the length of diagonal OA of square MOAN according to rule number 7. The length of diagonal OA according to rule number 7 will be equal to square root of 2 times the length of square MOAN sides, that is to say times 1. So the length of diagonal OA of square MOAN will be equal to square root of 2 times 1, that is to say to square root of 2 units. Likewise, the length, if you focus on the big square ABCD, the length of diagonal CA will be equal to the length of one side of square ABCD, that is to say to 4 units, times square root of 2. Okay, we found out that CA equals to 4 times square root of 2. I'll repeat again. We actually found out that the length of diagonal CA of the big square ABCD is equal to 4 times square root of 2 units, and the length of the small of the diagonal OA, that is the diagonal of the small square MOAN, is equal to square root of 2 units. Okay, so actually the length of diagonal CA is 4 times as large as the length of diagonal OA. Okay, in the next step we will calculate the length of line segment CO. From the drawing you can see that line segment CO equals to CA minus OA. Again, CA minus OA equals to CO. From the drawing you can see that CO equals to CA minus OA. That is to say, CO equals to CA, that is actually 4 times square root of 2 units. We already found out that it equals to 4 times square root of 2 units, minus OA, that is actually square root of 2 units. So actually CO equals to 4 times square root of 2 units minus 1 times square root of 2 units, that is to say it equals to 3 times square root of 2 units. So here we can write down that CO, line segment CO, equals to 3 times square root of 2 units, and we have already found out that OA equals to square root of 2 units, 1 times square root of 2 units. Okay? So in the next step we will focus on the right triangle COK, the blue right triangle COK, so we will focus on the blue right triangle COK. According to the Pythagoras theorem, in the right triangle COK, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. It is true in any right triangle, and especially in the right triangle COK. The hypotenuse in the green right triangle COK is CO. Therefore, the square of the hypotenuse is CO squared, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to OK squared plus CK squared. So I will repeat again. In the right triangle COK, in the right blue triangle COK, according to the Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. This is to say, CO squared equals to OK squared plus CK squared. But we have already found out that CO equals to 3 times square root of 2. So 3 times square root of 2 square equals to OK square. OK equals to 1, so OK square is 1 square is 1, plus CK square. I'll repeat again. CO equals to 3 times square root of 2, as you can see here. Therefore, CO square equals to 3 times square root of 2 square plus OK square. OK equals to 1, so OK square will be equal to 1 square is 1, plus CK square. CK square is CK square, that is the missing variable. So here 3 times square root of 2 square is 9 times 2, so I will write it down. In conclusion, we found out that 9 times 2 equals to 1 plus CK squared. 9 times 2 is 18, so I write it down. So we found out that 18 equals to 1 plus CK squared. We will subtract 1 from equation number 1 and we will get that 18 minus 1 is 17. 17 equals to CK squared. We will take a root out of this equation, equation number 1, and we will get that CK equals to square root of 17 units. So we found out that CK equals to square root of 17 units. So we write it here. That CK equals to square root of 17 units. In the next step, I will present to you the last rule, rule number 8. According to rule number 8, the lengths of two tangents from a common external point to a circle are equal. So I'll read rule number 8 again. According to rule number 8, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 8? The meaning of rule number 8 is that if we have this circle and this point, we define this point as point P. Point P is an external point in relation to this circle because point P, why point P is an external point? Because point P is not located inside this circle nor on this circle, but it is located outside this circle, therefore it is defined as external point of this circle. So if from point P we will draw two tangents to this circle, the first tangent will be this tangent, we will define the point of tangency of the first tangent with this circle is point A, and we will draw the second tangent from point P to the circle. So this will be the second tangent, and we will define the point of tangency of tangent. The second tangent with this circle is point B. So actually the length of the first tangent is PA, and the length of the second tangent is PB, and according to rule number 8, the lengths of two tangents from a common external point to a circle are equal. So whenever you draw two tangents to a circle from a common external point, like in this drawing, point P is a common external point, then the lengths of those two tangents will be equal to each other. That is to say, PA equals to PB. Again, whenever you draw two tangents from a common external point of a circle to that circle, then the lengths of those two tangents will be equal to each other. In this case, PA equals to PB. Okay, so we can implement rule number 8 in our drawing, because in our drawing we have the external point, point E, and from the external point E, we have two tangents to this circle. The first tangent is EN, the second tangent is EK. So, according to rule number 8, those two tangents are equal to each other. That is to say, EN equals to EK according to rule number 8. And if we define EN as X, so from this equality we conclude that EK also equals to X. So we define EN as X or NE, so therefore EK will be also equal to X, and we will find out the value of line segment EB. From the drawing you can see that line segment EB equals to AB minus AN minus NE. Again, AB minus AN minus NE equals to EB. I will repeat again. EB equals to AB minus AN minus NE. Okay, but we know that, so EB equals to AB is 4 units, minus AN equals to 1 unit, minus AB equals to 4 units, AN equals to 1 unit, and NE equals to X according to our definition. So in conclusion, we found out that EB equals to 4 minus 1 minus X, that is to say EB equals to 3 minus X. EB equals to 3 minus X. So actually we can write here that EB equals to 3 minus X, and this angle ABC, is the right angle because it is 1 out of 4 angles of square ABCD, and we know that all the angles inside the square are right angles. Therefore, this angle ABC equals to 90 degrees. So we focus on the right green triangle, triangle CBE. So on the right green triangle, triangle CBE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So actually the hypotenuse in the right green triangle, triangle CBE, it is actually CE. Therefore the square of the hypotenuse is CE square, and CE square equals to, according to CE square equals to the sum of the squares of the perpendiculars, that is to say it equals to EB square plus BC square. So I will repeat again. In the right green triangle, triangle CBE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say CE square equals to EB square plus BC square. But we know that CE equals to square root of 17 plus X. Therefore, CE square will be equal to square root of 17 plus X square, and it equals to EB square. EB equals to 3 minus X, so EB square will be equal to 3 minus X square plus BC square. BC, as you know that all the sides of a square are equal to each other, and we know that AD equals to 4 units, therefore BC will be also equal to 4 units. So BC equals to 4, therefore BC square is 4 square, 4 square is 16. So in conclusion, we found out that square root of 17 plus x squared equals to 3 minus x plus 16. Here we will open the brackets on both sides of equation number 2, and we will get that square root of 17 plus x squared equals to 17 plus x squared plus 2 times square root of 17 times x, and it equals to 3 minus x squared. 3 minus x squared is 9 plus x squared minus 6x plus 16. So here actually we have x squared on both sides of this equation, equation number 2, so x squared will get cancelled. And we also know that 9 plus 16 is 25, so we write here that 25 minus 6x equals to 17 plus 2 times square root of 17x. So here we will subtract 17 from this equation, equation number 2, and we will get that 17 minus 17 is 0, and here what is left is only 2 times square root of 17x. It equals to 25 minus 17 is 8 minus 6x. So here we will divide this equation, equation number 2, by 2, and we will get that 2 over 2 is 1, so here we will get square root of 17x equals to 8 over 2 is 4 minus 6 over 2 is minus 6x over 2 is minus 3x. So here we will add 3x to this equation, equation number 2, and we will get that square root of 17x plus 3x equals to 4. So we got here that square root of 17x plus 3x equals to 4. Here we will take out a common factor from this expressions in this side of equation number 2, and we will get that, so x is taken out as a common factor of these two expressions. So what is left from 17x after we took from it x as a common factor? What is left? It is actually square root of 17, and what is left from 3x after we took from it x as a common factor? What is left? It is actually 3 equals to 4. Here we will divide this equation, equation number 2, by square root of 17 plus 3, and we will get that x equals to 4 over square root of 17 plus 3 we found out that x equals to 4 over square root of 17 plus 3. So here we will multiply this side of equation number 2 by square root of 17 minus 3, and then we will divide it by square root of 17 minus 3. So we got this expression. We have in the denominator square root of 17 plus 3 times square root of 17 minus 3. We will find out the value of this expression according to the trigonometric identity that a plus b times a minus b equals to a square minus b square and in our specific expression a equals to square root of 17 and b equals to 3. So square root of 17 square will be equal to 17 minus b square. B is 3, so b square is 9. So in the denominator we found out that we have only 9. And we didn't touch at all and the numerator, so it will remain as it is. It is 4 times square root of 17 minus 3 so according to equation number 2, x equals to, in conclusion we found out that x equals to 4 times square root of 17 minus 3 over 17 minus 9. 17 minus 9 is 8, so we write it down. So we found out that according to equation number 2, x equals to, in the 17 minus 9 is 8, so in the denominator we have 8, and in the numerator we have 4 times square root of 17 minus 3. Here we will divide the numerator by 4 and the denominator also by 4. 4 over 4 is 1 and 8 over 4 is 2, so we will get in conclusion that x equals to 4 over 4 is 1, so it is actually what remains here is the square root of 17 minus 9. 8 over 4 is 2, so In conclusion, we found out that x equals to square root of 17 minus 3 over 2. And what is the area of the green square? The area of any square, the formula for the area of any square, it is actually the base times the height to the base over 2. So the area of the green right triangle CBE, according to question number 3, will be equal to the base of the green right triangle CBE is EB, times the height. The height is BC because the height must create 90 degrees with the base, and indeed BC creates 90 degrees with the base, so it is actually BC over 2. So the area of the green right triangle CBE will be equal to EB. EB is 3 minus x times BC. BC equals to 4 units over 2. So we found out that the area of the green right triangle CBE equals to 3 minus x times 4 over 2. 4 over 2 is 2, so I will write it down. Actually, this is the sign for the area. It means the area of triangle CBE. The squared brackets, it is the sign of area. Okay. So the area of the green right triangle CBE, according to question number 3, equals to 4 over 2 is 2, so it is 2 times 3 minus x. The area of the green right triangle CBE equals to 2 times 3 minus x. But we have already found out that the value of x, according to equation number 2, is equal to x equals to square root of 17 minus 3 over 2 . Okay, so here we will place the value of x, this value of x from equation number 2 inside x here from equation number 3, and we will get that the area of the green right triangle CBE equals to 2 times 3 minus x, and x equals to this expression, so we will copy it. It is actually square root of 17 minus 3 over 2. So we found out that the area of the green right triangle CBE, according to equation number 3, equals to 2 times 3 minus square root of 17 minus 3 over 2. Here we will multiply 3 by 2 and then we will divide it by 2 in order to have a common factor with this expression. And we will get that the area of the green right triangle CBE, according to equation number 3, equals to 2 times 6 minus square root of 17 minus 3 over 2. So here 2 over 2 is 1, so 2 will get cancelled. And what is left after we cancel 2? What is left, it is actually that the area of the green right triangle CBE is equal to 6 minus square root of 17 minus 3. Okay. The area of the green right triangle CB equals to 6 minus square root of 17 minus 3. Here we will open the brackets of this equation number 3, and we will get that the area of the green right triangle CBE equals to 6 minus square root of 17. So here we have minus 3 is plus 3. So in conclusion, we found out that the area of the green right triangle CBE, according to equation number 3, is equal to 6 minus square root of 17 plus 3. 6 plus 3 is 9. So we got that the area of the green right triangle CBE is equal to 9 minus square root of 17 square units. Or in terms of numbers, the area of the green right triangle CB equals to 4.88 square units. I will repeat again, the area of the green right triangle CB equals to either 9 minus square root of 17 square units, or in terms of numbers, the area of the green right triangle CB equals to 4.88 square units. So we'll see it in the drawing. The area of this green right triangle CB equals to either 9 minus square root of 17 square units, or in terms of numbers, the area of this green right triangle CBE equals to 4.88 square units. Okay, now I'll summarize the lecture. Actually, we wanted to find out the area of this green triangle CBE. We have R square ABCD. We know that one side of square ABCD equals to 4 units. And inside this square we have circle. The radius of this circle equals to 1 unit, and we want to find out the area of this green right triangle. So first of all, I presented to you a new rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 1? The meaning of rule number 1 is that if you have this circle and tangent AB is tangent to this circle at point M. Point M is the point of tangency of tangent AB with this circle. So if we have radius OM that is drawn to the point of tangency, then the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. So whenever you have a radius that is drawn to the point of tangency, then the tangent will be perpendicular to that radius. In this case, the tangent OM is drawn to the point of tangency, therefore the tangent AB is perpendicular to this radius. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. And we actually implemented rule number 1 in our drawing. Here we have this radius. The radius OM is drawn to the point of tangency, that is to say, it is drawn to point M, that is the point of tangency of tangent DA with this circle. Therefore, whenever you have a radius that is drawn to the point of tangency, then the tangent, in this case, tangent DA will be perpendicular to this radius, that is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. And we also know that all the angles inside the square are right angles, so therefore this angle that is 1 out of 4 angles of square ABCD must be a right angle. And here we have also the radius ON is drawn to the point of tangency, that is to say, it is drawn to point N, that is the point of tangency of tangent AB with this circle. Therefore, the tangent AB will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees and this angle also equals to 90 degrees. And then we connected together points O and K by a straight line. Line segment OK is the radius of this circle because of the fact that it starts from the center of the circle. That is to say, from point O and ends at point K, that is the point on the circle itself. Therefore, OK is the radius of this circle, and we have this radius OK, it is drawn to the point of tangency, that is to say, it is drawn to point K, that is the point of tangency of tangent EC with this circle. Therefore, the tangent EC will be perpendicular to this radius, that is to say, this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. Then I presented to you a new rule number 2. According to rule number 2, the sum of the angles in any quadrilateral is equal to 360 degrees. So we have here quadrilateral MOAN, and according to rule number 2, the sum of its angles is equal to 360 degrees. Which angles does this quadrilateral have? It has 3 angles, 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is angle X, must be equal to 360 degrees. So 270 degrees plus the size of angle x must be equal to 360 degrees according to rule number 2. We subtracted 270 degrees from this equality and we got that angle x equals to 90 degrees. That is to say angle x is the right angle. Okay, angle x is the right angle. So in quadrilateral MOAN we have 4 right angles, 1, 2, 3, 4. And we also have rule number 3. According to rule number 3, any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. And because of the fact that this quadrilateral MOAN has 4 right angles, according to rule number 3, it must be a rectangle, or at least a rectangle. So we relate to quadrilateral MOAN as a rectangle because it has 4 right angles, and according to rule number 3, it must be at least a rectangle. So we will relate to quadrilateral MOAN as a rectangle. And we also have rule number 4. According to rule number 4, the opposite sides of a rectangle are equal to each other. So in rectangle MOAN, its opposite sides are equal to each other. What does it mean? It means that MO equals to AN according to rule number 4. MO equals to AN according to rule number 4. But we already know that MO equals to 1 unit. It is given us the question. We know that OM equals to 1 unit, so from this equality we will conclude that AN also equals to 1 unit. So here AN equals to 1 unit. Likewise, MA equals to ON according to rule number 1. MA equals to ON according to rule number 4. Okay, but we know that NO equals to 1 unit. We've already found out that NO equals to 1 unit. So from this equality, we will conclude that MA also equals to 1 unit. Here, MA equals also to 1 unit. So, as you can see, all 4 sides of quadrilateral MOAN, they are equal to each other. They are all equal to 1 unit. And also quadrilateral MOAN has 4 right angles. Then I presented to you rule number 5. According to rule number 5, any quadrilateral that has 4 right angles and also 4 equal sides, then it must be a square. And because of the fact that quadrilateral MOAN has 4 right angles and also 4 equal sides, therefore quadrilateral MOAN is a square according to rule number 5. Quadrilateral MOAN is a square according to rule number 5. Okay? So we will relate to MOAN as a square. Quadrilateral MOAN is a square. And we also have rule number 6. According to rule number 6, the diagonals of a square bisects the angles of a square into 45 degrees angles. So if we relate to our square, the small square, square MOAN, then according to rule number 6, the diagonal OA bisects this angle, angle BAD, into 2 angles of 45 degrees. So this angle will be equal to 45 degrees, and this angle will be also equal to 45 degrees according to rule number 6. So in the square MOAN, angle OAB equals to 45 degrees. Angle OAB equals to 45 degrees according to rule number 6. Likewise, if we relate to the big square, square ABCD, Then the diagonal CA, according to rule number 6, bisects this angle into two equal angles that each of them is equal to 45 degrees. This is to say this angle equals to 90 degrees, and also this angle that is actually angle CAB also equals to 45 degrees. That is to say angle CAB also equals to 45 degrees according to rule number 6. And from the fact that those two angles, they are both equal to 45 degrees, therefore they are equal to each other. That is to say angle OAB equals to angle CAB. Angle OAB equals to angle CAB. From the fact that angle OAB equals to angle CAB, we will conclude that the diagonal CA of square ABCD passes through point O. Okay? We will conclude that the diagonal CA of square ABCD passes through point O. The diagonal CA must pass through point O, otherwise if we assume that diagonal CA doesn't pass through point O, then angle CAB will never be equal to angle OAB. But because of the fact that those two angles are equal to each other, we will conclude that the diagonal CA passes through point O. Then I presented to you rule number 7. According to rule number 7, the length of a diagonal of the square is equal to square root of 2 multiplied by the length of the square sides. So what is the meaning of rule number 7? The meaning of rule number 7 is that if we have this square ABCD, and we know that the length of one side of square ABCD equals to S units, then the length of its diagonals, that is to say the length of diagonal BC of square ABCD, will be equal to S times square root of 2 units. Okay? And we found out the length of diagonal OA according to rule number 7, it equals to 1 times square root of 2. So the length of diagonal OA equals to square root of 2 units. And likewise, we found out the length of diagonal CA of square ABCD. According to rule number 7, it will be equal to the length of the square side, that is actually 4 units, times square root of 2. So CA, according to rule number 7, equals to 4 times square root of 2 units, and OA equals to square root of 2 units. And then we found out the value of CO. CO, as you can see from the drawing, equals to CA minus OA. CO equals to CA minus OA. So CO equals to CA. CA is 4 times square root of 2 units minus OA. OA is square root of 2 units. So in conclusion, CO equals to 4 times square root of 2 units minus 1 times square root of 2 units. That is to say CO equals to 3 times square root of 2 units. So here CO equals to 3 times square root of 2 units. Then I presented to you, then we focused on the green and the blue right triangle, triangle COK. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right blue triangle, triangle COK is CO. So the square of the hypotenuse is CO squared, and it equals to OK squared plus CK squared. That is to say to the sum of the squares of the perpendiculars. We have already found out that CO equals to 3 times square root of 2 units. So CO squared will be equal to 3 times square root of 2 squared. OK equals to 1. So OK squared is 1 squared. 1 squared is 1. CK squared is CK squared. That is the missing variable. So here 3 times square root of 2 squared is 9 times 2. 9 times 2 equals to 1 plus CK squared. 9 times 2 is 18, so 18 equals to 1 plus CK squared. We subtracted 1 from this equation, equation number 1. 18 minus 1 is 17, so 17 equals to CK squared. we took a root out of this equation number 1, and we found out that ck equals to square root of 2 units. Okay, ck, here ck equals to square root of 17 units. Then I presented to you rule number 8. According to rule number 8, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 8? The meaning of rule number 8 is that if we have this circle and we have the external point P, and from the external point P we draw two tangents to this circle, then the length of those two tangents will be equal to each other. That is to say, PA equals to PB. Okay, we implemented rule number 8 in our drawing. In our drawing we have the external point E. From the external point E we have two tangents to this circle. We have tangent EN and tangent EK. And according to rule number 8, EK equals to EN, or EN equals to EK according to rule number 8. We defined EN as X, then according to this equality we will get that EK also equals to X. So here EN equals to X and EK also equals to X. Then we found out the value of line segment EB. From the drawing you can see that EB equals to AB minus AN minus NE. Again, AB minus AN minus NE equals to EB. EB equals to AB minus AN minus NE. So EB equals to AB is 4, NA is 1, and NE is X. So in conclusion, EB equals to 4 minus 1 minus X. 4 minus 1 is 3. So in conclusion, EB equals to 3 minus X. So we found out that EB equals to 3 minus X. Then we know that all four angles inside the square are right angles. Therefore in square ABCD, this one, it is 1 out of 4 angles in square ABCD, therefore it is a right angle, that is to say it equals to 90 degrees. Then we focused on the right great triangle CEB, and according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars in the right triangle CEB. The hypotenuse is CE, therefore the square of the hypotenuse is CE squared. It equals to the sum of the squares of the perpendiculars, that is to say it equals to EB squared plus BC squared. CE equals to square root of 17 plus X, so CE squared will be equal to square root of 17 plus X squared. EB equals to 3 minus X, so EB squared will be equal to 3 minus X squared, plus CB. CB or BC equals to 4 units, so BC squared will be equal to 4 squared. 4 squared is 16. Okay, so we got the square root of 17 plus X squared equals to 3 minus X squared plus 16. We open the brackets on both sides of this equation, equation number 2, and we got the square root of 17 plus X squared equals to 17 plus X squared plus 2 times square root of 17X, and 3 minus X squared equals to 9 plus X squared minus 6X plus 16. Here we have X squared on both sides of the equation. So X squared will get cancelled, and 9 plus 16 is 25. So in conclusion, we got that 17 plus 2 times square root of 17x equals to 25 minus 6x. We subtracted 17 from this equation, equation number 2, and we got that 2 times square root of 17x equals to 25 minus 17 is x. Here it is minus 6. We divided this equation by 2, and we got that square root of 17x equals to 8 over 2 is 4, and minus 6 over 2 is minus 3x. Here we added to this equation number 2, 3x, and we got that square root of 17x plus 3x equals to 4. Here we took a common factor x from this expressions and we got that x times square root of 17 plus 3 equals to 4. We divided this equation number 2 by square root of 17 plus 3 and we got that x equals to 4 over square root of 17 plus 3. Then we focused on this side of equation number 2 and we multiply this side of equation number 2 by square root of 17 over 3 and then we divide it by square root of 17 over 3, so we change nothing. It is allowable, and we found the value of the denominator that it's actually square root of 17 plus 3 times square root of 17 minus 3 according to the algebraic identity that a minus b times a plus b equals to a squared minus b squared. Here in our specific example we have that a equals to square root of 17 and b equals to 3. Okay, so so this expression equals to a squared minus b squared. A squared, it is actually square root of 17 squared is 17 and b is 3, so b squared is 3 squared is 9. So in conclusion, in the denominator we left only with 17 minus 9, so this expression in the denominator equals to 17 minus 9 and we didn't touch the numerator at all, so it remains as it was. So we copied the numerator as it is and we found out that s equals to 4 times square root of 17 minus 3 over 17 minus 9. 17 minus 9 is 8, so in the denominator we have 8 and in the numerator we have 4 times square root of 17 minus 3. So in conclusion, x equals to 4 times square root of 17 minus 3 over 8. We divided the numerator and the denominator by 4. 4 over 4 is 1 and 8 over 4 is 2. So in conclusion, we got that x equals to square root of 17 minus 3 over 2. And we want to find out the area of the green right triangle. The area of the green right triangle equals to the area of any triangle equals to the base of the triangle times the height to the base over 2. So we will use this formula in order to calculate the area of the green right triangle, triangle CBE. So the base of triangle CBE is EB and the height is BC. So the area of the green right triangle CBE will be equal to EB times BC over 2. But we know that EB equals to 3 minus x and BC equals to 4. So in conclusion, we got that the area of the green right triangle CBE equals to 3 minus x times 4 over 2. 4 over 2 is 2. So in conclusion, we found out that the area of the green right triangle CBE equals to 2 times 3 minus x. That is the area of the green right triangle CBE. So here x is missing, but we have already found out that x equals to, according to equation number 2, x equals to square root of 17 minus 3 over 2. So we will place the value of x from equation number 2 inside x in equation number 3 here. So we did it and we found out that the area of the green right triangle CBE equals to 2 times 3, and this is x actually. Square root of 17 minus 3 over 2 is x from equation number 2. Here we have 3 minus this expression. We multiplied 3 by 2 and then we divided by 2 in order to have a common factor with this expression. And we got that the area of the green right triangle CBE equals to 2 times 3 times 2 is 6, so 6 minus square root of 17 minus 3 over 2. Here we divided this equation number 3 by 2. 2 over 2 is 1, so 2 will get cancelled. And we, in total, in the conclusion, we found out that the area of the green right triangle CBE equals to 6 minus square root of 17 minus 3. We open the brackets in this equation number 3, and we found out that the area of the green right triangle CBE equals to 6 minus square root of 17 plus 3. 6 plus 3 is 9, so in conclusion we found out that the area of the green right triangle CBE equals to either 9 minus square root of 17 square units, or in terms of numbers, the area of the green right triangle CBE equals to 4 minus 88 square units. I repeat again, we found out that the area of this green right triangle CBE equals to either 9 minus square root of 17 square units, or in terms of numbers, the area of this green right triangle CBE equals to 4.88 square units. Okay, thank you very much.